Okay. All right, thank you. Our next mathcast in our sequences and series chapter is going to be geometric sequences. So before we saw our first type of sequences were arithmetic. This type will be called geometric. And in a geometric sequence, terms are generated using a constant common ratio, r. So as we jump from step to step, we are multiplying by a number. We're not adding and subtracting, we are multiplying or dividing as we go step to step. So that makes it geometric. When we multiply, it's a geometric sequence. So here we could be asked the question, find the fourth term of 2, 6, and 18. This is the first term, that's the second term, there's the third term. We could find the fourth term just by looking at it. 2 times 3 is 6, 6 times 3 is 18, and 18 times 3 is 54. We don't want to always have to draw these dashes and use these multiply, especially if you're not asked to find the fourth term, but suppose you're asked to find the 400th term. So we're going to look for a pattern and try to write a model, an equation, or the general term for a geometric sequence. So we look at some patterns here. So we see term 1 has a value of 2. And then we see term 2, it starts with our first value, 2, and we just multiplied it by 3 once. Okay. Then we see term 3, which is 18. How do we get 18? We start at 2, and we multiply by 3 twice to get there. So we start at 2, multiply by 3 once, twice to get there. We look at term 4, which is 54, and we see, okay, we started at 2, and we multiplied by 3 times. So 1, 2, 3 times to get us over to that 54. Now, is there a pattern in here? We see, well, yeah, we are starting at the same value, 2, every time, which is given to us. We see that we are multiplying by 3 every time. And we see we have these times 3's in there. And again, we see that the numbers are just offset by 1. Term 2, it's 1 multiply. Term 3, it's 2 multiply. And term 4, it's a 3 multiply, because we already have that first number in there. We can put some variables to this. We're going to call this the 2, U1, our first term. We're going to use R for that common ratio. Again, any term we're trying to find, we'll call it UN. And our power is n minus 1. We're always 1 shy of the number we're trying to find. So if it's a 4, it's 3 multiplies. If it's a 3, it's 2 multiplies. And these all get put together. This times this times this, which is just this product here. That all gets put together into the general term of a geometric sequence. So we can go back to our initial question here and try to find the answer using our formula. We know it works out to be 54. We're going to use the formula here. U1 is 2. R, we're multiplying by 3 every time. And we're being asked for the fourth term, so n is equal to 4. We plug this all in. 2 times 3 to the 4 minus 1. 4 minus 1 is 3, of course. 2 times 3 to the 3. 2 times 27, which is 54, which is correct. A more challenging question, it could be find the 12th term. So I have my formula. UN equals AR to the n minus 1. A is my first term, 110. R is what I'm multiplying by every time, 2. And if I'm asked to find the 12th term, that's U12, I know my power is going to be 12 take away 1. So this becomes equal to 110 times 2 to the 11. And I plug that to my calculator, and it's 225, 280. Okay, that's it. Take a look at the questions on page 46.